Let's go ahead and start with a function. We're going to use 2x plus 4 is equal to y. So we're going to create an input-output table. So on the left side we have our input x, and remember, we can choose pretty much whatever we want it to be. And on the right side we have our output. Now our output is going to be created depending on what our input is, so we don't get to control that. Our input x, we're going to choose 1, 2, and 3. Why not just keep it simple? So for our first input, x is 1, we take the function, and in place of x, we put 1. We end up with 2 times 1 plus 4. 2 times 1 is 2, so 2 plus 4 equals 6. So this tells me that when we input 1 for the x place, we end up with y equals 6. So that's our output. For our next example, let's go see what happens when we input 2 for the x's place. We end up with 2 times 2, which goes where the x is, plus 4. 2 times 2 is 4, so we get 4 plus 4, which is 8. That means that when we input 2 in the x's place, we end up with a y value of 8, and that is our output. What happens when we input 3? See if you can do it mentally or on paper. Alright, once again, here's our function, and we're substituting 3 for the x value, and we end up with 12 plus 4, oops, even I make mistakes, 6 plus 4, and that is equal to 10. Fantastic. We have a pretty good input-output table going now. So we have input of 1, 2, and 3 gives us an output of 6, 8, and 10. Let's go see how that translates into a graph. I'm going to go ahead and put 1, 2, and 3 on my x-axis and 1 through 10 on my vertical y-axis. And I'm going to graph 1, 6 first. So I go to 1 on my x-axis, and then I go up to 6 on my y-axis, and there's my first coordinate. Now I'm going to do 2, 8. So I go to 2 on my x-axis, 1, 2, and I go up to 8 on my y-axis, 1, 2, 3, 4, 5, 6, 7, 8, and there it is. There's my second coordinate. Now I'm going to find 3, 10. So I go to 3 on my x-axis and I go all the way up to 10 on my y-axis. And I can see my 3 dots line up perfectly, and therefore I know that my function is correct. Great job.